assuming that you travel forward in time. That seems to be the time travel we do have down. All right. Not enough time really to graph it, but one advantage of this is, it's a little less abstract, but you know where, if I'm graphing position, you know where that's below the axis, you know where it hits the axis, you know where it's above the axis. It's already laid out for you here. However, we can do one other thing here. If I have a position versus time graph, and it looks like this, what would my displacement time graph look like? It would go down and then up, so sort of flip.
Yeah.
How would you, give me a rationale for that? Okay. You agree?
So the start would be then 0.
Okay.
Okay. This.
I assume there was more coming. Or if anyone wants to build off of what Ibrahim has started here.
Could it be an inverse with the graph?
If it's the inverse, that means, so if it's this, which is what Ali was sort of suggesting, that means that from here, you go in the positive direction, but for displacement, you go into the negative direction. You suddenly have defined two different directions as positive, which, now granted, there was a street in Wilmington, Delaware, where there was 2 one-way signs pointing in opposite directions, but typically not done.
So it would essentially just be from the origin to the end point, just a line to the.
No, that. All right, so if I've got a position here and displacement, we'll do some meters. So if this is 5 meters and then 6 meters, so I've gone 1 meter in the positive direction. If I start at 0 here, where will I be at this point? If this is 7, what will this be?
8. No.
If this is 3,
4. Wait a minute.
they are paralleling each other. If I go, this is the change in position. If my change in position is 1, my change in position here has to be 1. I go from here to here, that's 2. I go from here to here, that's -2. What my displacement graph will look like is it starts at 0, and then it will just sort of map that, except it is that far below.
I got the origin right though.
That's my displacement graph. Which is why when I asked for the graph, I asked for position and asked for position and displacement.
So, I have a question that's.
It's the same, just shifted down.
It's kind of like that. So when you have like in electronics and stuff, when you say you're 180 degrees off, so would that be like 180 degree displacement?
No, generally when you talk about 180 degrees off on something like a curve like this, you're talking about a shift this way.
Okay.
That if that were a sine curve, that would be 180 degrees, that's 360 degrees, 0 degrees, and so 180 degrees off, it would shift one way or the other.
Okay, so it's the horizontal, not vertical.
Right. Yeah, the 180-degree shift is more like a melody, and this is more like chord.
Okay.
I'm trying to remember what the jazz professor called it. Melody is a horizontal consideration. Yeah, what we call the vertical.
Well, so.
That was appreciation of jazz. The only person I've ever heard to use the word cat in reference to a person and not be saying it sarcastically or ironically. Yeah, I was playing jazz with this cat down at this French bistro. Anyway. And on that beautiful note, don't forget tomorrow, I'm expecting the first lab, they handed in at the beginning of lab. We're gonna meet down in the other room. Pre-lab for the second lab, also handed in at the beginning. And I think that's pretty much that. I expect probably to be done with chapter 2. I'd like to think Thursday. And at that point, we'll assign when master set 2 is due and the in-class quiz on chapter 2.
I had a question. Where are the practice problems that you said that were going to be on the quiz on Thursday?
Where's the lobbies?
Because I looked